Hello students, welcome to another lecture session. So in this video, let us prove the three important trigonometric identities. Now what are they? The first one being sine squared a plus cos squared a equals 1. To prove this, let us consider a right angle triangle. So in this triangle, you have 90 degrees at B. So now using Pythagoras theorem, we have the hypotenuse, which is AC square, equals AB square plus BC square. Now let me divide the entire expression by AC square. So you divide the expression, let me call this as 1, by AC square. So you have AC square by AC square equals AB square plus BC square divided by AC square. So this is 1 equal to AB by AC the whole square plus BC by AC the whole square. So considering angle A here, what is AB by AC? AB is the adjacent side and AC is the hypotenuse, right? So the adjacent side by hypotenuse is cos A the whole square and BC is the opposite side. The opposite side by hypotenuse is sine A the whole square. So we have sine squared A plus cos squared A equals 1, which is the first important trigonometric identity, which I've already listed here. The next important trigonometric identity is 1 plus tan squared A equals secant squared A. So again we consider this expression by Pythagoras theorem. So now let me divide 1 by AB square. So you have AC by AB the whole square equals, so I am dividing RHS by AB square. So I have AB by AB square plus BC by AB square. So what is AC by AB? So I have AC by AB, that is hypotenuse by the adjacent the whole square equals 1 plus what is BC by AB? So you have BC, which is opposite by AB, which is the adjacent the whole square. Opposite by adjacent is nothing but tan. So you have 1 plus tan A. So with respect to A, angle A, opposite by adjacent, the ratio of opposite side by adjacent side is tan A. So you have 1 plus tan A the whole square equals, we know that adjacent by hypotenuse is cos, the reciprocal of cos is secant. So this is secant square. So I get the relation 1 plus tan squared A equals secant squared A. So the third identity is 1 plus cot squared A equals cosecant squared A. So now in the previous case, to prove the second identity, we divided equation 1 by AB square. So now to prove the third identity, we have to divide equation 1 by BC square. So divide 1 by BC square. So you get AC by BC the whole square equals AB by BC the whole square plus BC by BC. So BC by BC the whole square. So this is 1. So AC by BC. AC is the hypotenuse, BC is the opposite, the whole square. AB is the adjacent, BC is the opposite side, plus 1. So we know that opposite by adjacent is tan, whereas adjacent by opposite is cot. So this is cot A the whole square plus 1. And here you have hypotenuse by opposite. So we know that opposite by hypotenuse is sine, whereas its reciprocal is cosecant. So you have cosecant squared A. So we have the identity 1 plus cot squared A equals cosecant squared A. So hence, considering the triangle, the right angle triangle ABC, and by using this relation, that is the hypotenuse square is equal to sum of the squares of the other two sides and dividing them by each. So in the first case, to prove the first identity, we divided equation 1 by AC square. To prove the second identity, we divided equation 1 by AB square. And to prove the third identity, we divided the same equation 1 by BC square, and we get these three trigonometric identities. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads. And thanks for watching.